Okay, question 15. Once again, you see trig, you should be looking at the front page to get your trigonometric formulae. So we're solving this first question, so sine and cos. Now usually when you see sine and cos together, you think it's wave function, something like that, but you've got the 2x in there. So the minute you see sine 2x or cos 2x, you're wanting to sub in to make it an easier solve. Okay? Now what we would sometimes do is make sure we turn this into a trinomial, so it'd be cos squared and cos and then a number, and then solve it like a trinomial. But with sine 2x, I've just got the one expansion, so I'm going to say that if I sub that in, I'll get 2 sine x cos x plus 6 cos x. So it takes away the unknown. So if you've got a cos 2x, you're like, which one do I pick? And you're trying to pick the one where you've got the same term. So you've got cos squared and cos, or sine squared and sine, so you can make your trinomial. But in this case, I've only got that one, and that makes it a wee bit easier. You don't have to worry. So you know that's the right substitution. It's the only substitution you've got. And then you're thinking, well, how can I start to solve this? It's going to be a common factor. You can take out 2 cos x, and then you're going to end up with sine x plus 3. So it's either going to be this version or the trinomial. So when is 2 cos x equal to 0? 2 cos x, when does that give me 0? So let's think about it. I'll divide both sides by 2 in a wee sec. 2 cos x looks like this, doesn't it? 2 and negative 2. It looks like that. So when is that equal to 0? It's just those 2 points in there, yeah? So that's going to be 90 and 270. Now you could have divided both sides by 2 to get cos x is equal to 0, just regular cos x equal to 0, which would have been this one. I draw it right. Terrible drawing, but still crosses through those same points is the point I'm making. It's just got a different height, So if you wanted to divide by 2, that's fine, but you don't have to. You can just say, well, when is that graph at 0? So that's your first answer, and then your next answer, you're saying, well, when is sine x plus 3? When does that equal 0? Well, that means when does sine x equal negative 3? Let's have a think. So my regular sine x is doing something like this. It goes up to 1 and negative 1. Does it ever reach 3? No, it doesn't. That's an invalid solution. Yeah, it can't equal negative 3's down here somewhere, isn't it? Negative 3's. I'll draw that in. Negative 3 be down here. So it can't possibly reach negative 3. So that's your two answers. You've got 90 and 270. That's inside the range as well. And we're working in degrees, so watch out for that. So I'll just say invalid. Just to be really clear, I'll say invalid, no solutions. Just to be in line with the marking scheme. And that is you. So look, you're getting your mark for your substitution up here. You're getting a mark for your factorising. You're getting a mark for this line. And then your final mark for your interpretation. So really, really good question. Really, really nice question. Part B, so we've got a hence. The word hence always means look at what you've just done. Solve this. Okay, well, let's think about it. I just solved sine 2x plus 6 cos x. I just solved for that because we said that that was the same as this. Okay, so I've solved that one. And now it's asking me to solve, let's see, sine 4x plus 6 cos 2x. So what's happened to this thing? Well, they've times this by 2, that's been times by 2, and that's been times by 2. So what does that actually mean? Well, it means that the period has, halved, doubled effectively. Okay, so whatever if I've got a function here, if I've got sine x, okay, then the period is 360. If I've got, I'll do it in another graph actually. If I've got sine of 2x, it's doing something more like this, isn't it? So if that's sine of 2x, then the period is 180 degrees because it's resetting every 180. So this seems then that because we're times them by 2, we're halving the period. Okay, so whatever the period was here, we're halving it. So that means I'm going to take these solutions and I'm going to halve them. Okay, so I'll say, right, x is going to be equal to 90 divided by 2 and 270 divided by 2. So I've got 45 degrees, and what's that? 135 degrees. as well. But I'll now need to add on the period. So the period before, when we solved it, if you look at this, we've just got regular x's. So don't be confused. Don't look at this and then go, what's the period? Is it 180? Or when we rearranged it, our period here was 360. So this means the new period is going to be 180. So I'm going to add on 180 degrees to both of them. So I'm going to end up with 225 degrees and 315 degrees. So slightly tricky for 1 mark. It's quite a lot really when you think about what you're having to think about. But the point is you're trying to identify that the period has been halved. And like we said before, next to the x, you do the opposite. We move things. So it doesn't mean we're doubling the period, but we're halving it. But yeah, understanding that your period originally here was your 360. If you look at the results, it makes sense that it's 360. You're solving for cos x and sin x in the end, and now we're doubling that. Yeah, so if we were to that 2 is to filter its way through, we'd have twice the waves. Okay. So I hope that was helpful. And I'd say the big takeaway from this: you see sin 2x or cos 2x, get in here, get your substitution. This was a common factor factorizing. But a lot of the time, it can come out as a trinomial. So you'll end up with something like, I'll just write down here, something like sin squared x plus sin x plus 2. And what I tend to do is I tend to say something like big X or big Y is equal to sin X, and then I just solve it like a normal trinomial, like that. Do you know what I mean? So just watch out for those kind of ones, all right, where you've got the square. And that means you want to substitute in something which will give you the cos squared or whatever, so you get the same terms all the way through. Okay, nice one.